All right, vertical circular motion. Okay, a sphere of mass 5 kilograms. So we have a mass here. Let's write down. This is a mass. It's tied to a string. It moves in a vertical circle. This is a vertical circle of radius 0.55 meter. So this circle has radius 0.55. So this is the radius value. Okay. So at a constant speed of 3 meter per second. So look at this one. This is a speed in meter, meter per second. So this is the V value, V value, not omega, not the angular speed. Angular speed is radian per second. This one is meter per second. So it's V, not omega. Now determine the tension of the string at points A, D, E. So I need to find the tension. Okay, tension in the string. So we have the radius already. Okay, the radius value is 0.55. Okay, so now to determine the tension, we need to draw free body diagram for each point. Okay, so let's begin with point A. Okay, let's begin with point A. Right, this is the point A. Okay, so I don't want to draw the radius here. Okay, so let's draw the free body diagram directly on the figure. Okay, directly on the figure. So at point A, okay, the center is actually at the bottom. Yeah, this is the center of circle. So what is the force acting on the ball? What is the force acting on the ball? This one is the V. This is the V. So this is not a force. This is velocity. Now, what is the force acting on the ball at point A? It is attached to a string, isn't it? And the string is pulling on the ball, So the tension is downward. Always tension. Okay, let's say this is the point mass. Tension always away from object. Remember, tension always away from object. Tension always away from object. So this one, tension away from point A, away from object A, tension like this. And then we have some more. Okay, and then we have the weight of the ball. So which is mg, the weight of the ball. Okay. And then I think that's all the forces on the ball at point A. So what about the acceleration? Acceleration on the ball. So the acceleration always towards the center of circle. Yeah, remember centripetal acceleration always towards the center of circle. Now the center of circle is at below here, below point A. So the centripetal acceleration should be directly downward. Directly downward. This is the centripetal acceleration. Downward. Yeah, why downward? Why centripetal acceleration downward? Because direction is towards the center of circle. Okay. And then we can label there the positive and negative sign according to the Newton's second law. Yeah, remember? Do you remember this one? Newton's second law. When we have acceleration, we need to compare the force with acceleration. Yeah, refer back to Newton's second law. Because you apply the formula, total force equal to ma. The resultant force is actually the centripetal force. And the acceleration here is the centripetal acceleration. Okay, so where we have acceleration, follow acceleration, we put positive force. Opposite the acceleration, put negative force. Okay, this one. Okay. So, so going follow acceleration, which is downward, is a positive force. Opposite the acceleration is a negative force. Okay. And we only have the y component. Do you see that? We only have the y component. Since the acceleration is in the y component, so we only do y component. Okay. Let's do it. So for the y component, we can find the resultant force. Resultant force for y component, okay, is mass times acceleration, and the acceleration here is what? Is the centripetal acceleration. And what can we say about this resultant force? It is actually the centripetal force. Fc equal to mac. Okay, so now let's find out what are the forces in the y component. We have the tension and the mg. We have the tension and the mg, yeah, tension and the weight. So both of these, they are same direction with acceleration, isn't it? Tension and the weight. Okay. Okay. Now, okay, sorry. Where are we? This one. Yeah. Remember, follow acceleration. Forces that are follow direction of acceleration, they are positive force. So you see this tension and the weight, they all follow direction of the acceleration. This acceleration downward because towards the center of circle, yeah, because it is the centripetal acceleration. Okay. So I just want to label all the acceleration first for all these different position. Like if downward here, the center is above point E. So the centripetal acceleration for the mass E is going upward. You see that? So follow acceleration positive, opposite acceleration negative. So depend on where is the ball. If the ball is over here, the center of the path is at the left hand side of the ball. So the centripetal acceleration is towards the left, going left. Why going left? Because the center is at the left hand side, so centripetal acceleration must always towards the center of circle. You see, no matter where is the position of the ball, the centripetal acceleration always towards the center of circle. Always towards the center of circle. Yeah, going down, going up, going left, all directed towards the center of circle. And like for point D, follow acceleration, you should put positive, opposite you should put negative. So it all depends on where's the ball. Remember, the centripetal acceleration always towards the center of circle. Okay. So and it all backs to when we want to do this, we all use back the same concept, which is what we call the Newton's second law. We all go back to the chapter forces. We learn Newton's second law. So we also apply Newton's second law in our chapter circular motion here. Use back the same concept, okay, and use back the same formula. This one, yeah, maybe is fx or fy, total fx or total fy, and the sign also follow this one. Yeah, follows the same one. Okay. Okay, go back to point A. Yeah, go back to point A. So now, what are the forces in the y component where we can find the centripetal acceleration? There is the tension and the mg, the weight of the ball. So these two forces, they same direction with the acceleration. Same direction with acceleration. So these two forces, they are positive. They are positive. So both of them are positive. So we can write it as T plus mg. Okay. Both of them are positive because the same direction with acceleration, okay, and equal to MAC. Well, we don't have the AC yet. We don't have the AC yet, so we need to find AC first. Maybe not necessary also, because we can, AC. What's the formula for AC? AC formula is what? V square over R, or R omega square, or V omega. And what information do we have? We have the V, speed, and we have the radius, isn't it? So we just apply V square over R. We apply this one. Okay, we apply this one. So we can actually substitute AC with V square over R. Yeah, we don't use the R omega square because it gives us the V. We give us the V, we use the V square over R instead of R omega square. Normally these two we use and now is using v square over r because it's provided v instead of omega. Okay, so we can actually substitute the formula over here. Mv square over r. Okay, mv square over r. Or you want to find the value AC first here, also can. Yeah, AC, once you get the value of AC, you substitute here, also can. But you want to substitute the formula here, also can. Yeah, mv square over r. Actually, the centripetal force is actually mv square over r. That's the formula for, mv square over r is actually the formula for centripetal force. Okay, yeah. So okay, let's continue. So T plus mg equal to this one. So let's substitute the given value, the mass, the v, the r, and we can get the tension. Okay, so tension plus, what is the mass? 5 kilogram times gravity equal to 5 times, what's the v? V is 3. You see, v is 3. And then r, what is the r? Where's the r? Come on, where's the r? 0.55. 0.55 meter. So let's calculate and find the tension in the string. Alright. So I get the answer is, my tension is 32 point what? 32.77. 32.77. Okay. Newton. This is the force. Tension is a force, so it's Newton. So is it correct? A little bit difference, okay, but it's very near, so it's correct. Okay, it is correct. Okay, now let's investigate. I want to carry this one, go to this side. All right. Now, okay, I want to okay, I want to separate this. I want to do the next point. Okay, so now let's do point what? Point D. Point D. Let's do the point D. Okay, point D. Point D. So point D. Okay, where is the? Let's draw the free body diagram first. Yeah. Okay, let's draw the free body diagram. What force do we have on point D? What force do we have on point D? So point D, it has the of course tension. Yeah, tension. The string is pulling on. Yeah, this is the point mass. Okay, the tension, the tension is pulling on the ball, so the tension is to the left. Okay, and then we have the mg downward. Yeah, we have the weight downward. Mg. We have the weight downward. Okay, and I think that's only the force. Yeah, only the weight downward and the tension. Okay, so which component we need to consider? Which component? Is it the x component or the y component? We need to look at where is the AC. The AC is the, all right. Okay. Which component we use? X component or y component? To consider which component to use, we look at where is the AC. Our AC is in the x component for point D. So x component we use. Yeah. So we use x component. Because there we can find our centripetal acceleration. Last time point A we use y component because the AC, the centripetal acceleration, is in the y component. Okay. So x component. Now point D we use x component. Okay. We use x component because our centripetal acceleration is in the x component. Okay. So now so in the x component, okay, in the so in our x component have the centripetal acceleration. Yeah, that means it has a resultant force. resultant force in the x component. So that is total Fx. Okay, total Fx equal to MAC. MAC. Okay, which is Fc. This is Fc, right? So okay, what force do we have in the x component? The tension, and the tension is same direction with acceleration, so it is a positive force. So that's the tension. What other force? No more. Okay, mg is in the y component. Yeah, it's not involved in the AC. It's not involved in the x component. So only the tension involved in the x component, AC. Yeah. So okay, that's the only force. Is same direction with the acceleration, is positive. Okay, and then tension equal to MAC. I think that's it. Okay, and then tension equal to mv squared over r. Okay, so we can find our tension. Just substitute the mass, the v, and the r. Okay, so what is our tension? Let's calculate. Okay, so the answer which I get is 81.82. 81.82 Newton. So is the answer correct? Yes, that's correct. 81.82 Newton. Okay. Right. Very simple, right? Okay, 81.82 Newton. Okay, lastly, about point E. Okay, let's check the point E. Okay, let's check the point E. So, point E. Point E at the bottom here. So, how to do the point E? Yeah. So, point E. Okay, let's do point E over here. Never mind. For 1 second. Yeah, I rearrange a little bit. Okay. So now point E. Yeah. Let's do point E. Look at point E. Okay, let us first draw the free body diagram. What are the forces acting on the point E? Okay. Now, okay, this is the point mass. The string pulling on the ball, You see, the tension always away from object. You see that? Away from object, away from object, away from object. Always, the string only pulls, never pushes. Okay, pulling. And then this, the weight of the ball, is going downward, right? Weight of the ball is going downward, mg. Okay, the weight of the ball is downward. All right. Okay, let's look carefully. Yeah, let's look carefully. So the weight of the ball is downward. Okay, the weight is always downward. You see that? The weight is always downward, downward, downward. Is there any other force? No more. Yeah, only these two forces. Okay. So here, okay, so for this case, for point E, what component we consider? X component or Y component? Which component? Okay, which component do we use? Okay, we only choose the component which has the centripetal acceleration. Okay, because that is where you can find the resultant force. Okay, when you have acceleration, means you have resultant force. When you have acceleration, means you have resultant force, and the resultant force is the centripetal force. The resultant force, when you have acceleration, means you have resultant force, isn't it? Because resultant force is proportional to acceleration. So when you have acceleration, you must have resultant force, and that resultant force is the centripetal force. Because centripetal force is actually resultant force. centripetal force is actually resultant force of existing force. Still remember the concept I teach you about this one? This one? See that? What is centripetal force? Centripetal force is a resultant force from existing force. So we look for the resultant force. And to look for the resultant force, we look for the centripetal acceleration. We look for the centripetal acceleration. Okay, remember the step. We always look for the centripetal acceleration. Okay, the centripetal acceleration is where you can find the resultant force. It's where you can find the resultant force. Okay, and the resultant force is the centripetal force. You look for this one. First, you look for centripetal acceleration, and the centripetal acceleration is the one who will give the resultant force. The resultant force is the centripetal force. Remember the step. Okay. So go back to these questions. So for point E, our centripetal acceleration is in the y component. So we do the y component. Because our y component is where the centripetal acceleration. You have centripetal acceleration. Means you have centripetal acceleration means you have resultant force there. Okay, the resultant force is the centripetal force. Okay, so my resultant force is in the y component. There you can find the centripetal acceleration, and that resultant force is the centripetal force. Okay, so okay, follow acceleration positive, opposite the acceleration negative. Follow this one. Follow what you have learned in Newton's second law. Okay, previously. Follow acceleration positive force. Opposite acceleration is the negative force. So, okay. So, which force follow acceleration? Tension, because acceleration going up, tension also going up. So, tension is positive. Okay, put as positive tension. Tension is a positive. How about the mg? Mg is downward. Downward is opposite the acceleration. Acceleration upward, mg downward. So it's opposite. So it's a negative. We put as negative. Negative mg. Okay. And then this is MAC. And then AC we can substitute with V squared over R again. So the formula becomes AC is V squared over R. So become MV squared over R. MV squared over R is actually FC. See that? Yeah. Actually, you can see the ways to find centripetal force. There are two ways. You can find FC equal to this or equal to this. So actually, what I can say is what I want to say here is FC is actually mv squared over r. That's usual. Or FC, you want to find FC is actually tension minus mg. For point E lah. For point E. For point E. You see that? So tension this way lah. Okay. So for to find centripetal force, you have two formula. But now we're not going to find centripetal force. Our focus is not finding centripetal force. We want to find tension. We want to find tension. Okay, now let us do it. Yeah, to find the tension. So what is the mass again? The mass is 5. So 5 times gravity equal to 5. What's the V? V is 3. Okay, V speed, linear speed is V3, and then the radius is 0.55. Okay, so what is the tension here? Let's check. Yeah, let's check the answer. Okay. So I got the answer is The tension is 130.87 Newton. Is the answer correct? Is the answer correct? Yes. 130.85. Okay, almost near, yeah. So okay. So you see, tension at different point different. Okay. Normally, you see tension at the bottom. This is the tension at the bottom. It is always the highest. And tension is the lowest at the top. At the top, tension at the top is the lowest. So we can see actually the tension of the string at the bottom is most taut. It's easiest to break at the bottom because it has very high tension. But when the ball go to the top, the ball is like dropping, you know, the ball is like going to drop. So the tension of the string when the ball is at the top, the tension of the string here is actually very loose. Very loose. It has the lowest tension. You see, only 32 Newton. Only 32 Newton. But at the bottom here, the tension of the string is very taut. The string is very taut. It has 130 Newton. So here has very high tension. Here has very low tension. So the string easiest to break at the bottom because it has the highest tension of string when the ball is at the bottom. If we look back to the formula, look back to the formula here. Okay, this is just want to label first. This one is at the top position and this one is at the bottom. So at the top here, tension is the lowest. At the bottom here, tension is the highest. So if we compare these two formula, let's compare the formula. This one and this one. Let's compare these two formula. You will see the difference. This one you will get, put the tension at the front, so we will get mg. When we transfer the negative mg to the other side, we will get mg plus mac. However, for this one, if we transput the tension, put the mg go to the other side. Put mg go to the other side. So what do we get? Okay, maybe I should rearrange the formula. Okay, let me rearrange the formula here. So maybe I put as mac plus mg. Okay. So okay, you see that negative mg go to the other side, become positive mg, isn't it? All right. How about this one? This one go to the other side. What do you get? You will get mac minus mg. That's the difference. You see that? This one plus mg, this one minus mg. From the same, this one mac is constant. This one is these two, they are constant. They are constant. Why constant? Because mac is mv squared over r. The v here, this v is constant. This v is a constant speed, isn't it? Because of what? Because of the let me write it down. Because of uniform. Oops, sorry. Okay, make it bigger. Because of much bigger. Because of uniform circular motion. Because of this is a uniform circular motion. You see that? Uniform circular motion. That means the v is constant. When the v is constant, mv squared over r also constant. Mac also constant. This is the Fc actually. This is a centripetal force. The centripetal force is constant. MAC, this MAC is actually FC. It's constant. Okay, so that's why this is the tension at the bottom. This is the tension at the bottom. This is the tension at the top. So at the top, it has the lowest tension. Why it has the lowest tension? Because it minus mg. You minus something, the value becomes smaller. And that's why lowest tension. Minus the own weight. You know, when the ball at the top, the tension of the string has minus by the own weight, because the weight is going downward also. So minus by the own weight, the tension become lower. Yeah. But at the bottom here, the tension here have to overcome the own weight, have to support the weight going downward. Yeah, this string have to pull even harder. The tension have to pull even harder because need to overcome the own weight of the ball. Need to support the own weight of the ball. That's why it plus mg. You see that? Tension at the bottom is at the highest because plus mg, when negative mg go to the other side, become positive mg. MAC is constant. So the difference is just plus mg and negative mg. Because of plus mg and negative mg, that's what makes the tension different value between the top and the bottom. Okay, so I hope you understand. Okay, this. So important thing is you must draw the free body diagram. Identify which component, is it the x component or the y component, which has the centripetal acceleration. There you can find the centripetal force. There you can find the resultant force, which is the centripetal force. Okay, so that's all for these questions.